Okay, good morning everybody, and welcome to the second part of Newton's law, so his second law, and we're looking at connected bodies this time. So this is taking it that little extra step from what we covered in the last class. I'm going to go through one example in a fair bit of detail, and then in the notes you'll see that there's a question for you to have a go at before you go on to answers question 11, 12 and 13 in the 10.2 question review in your textbooks. Alright, so Newton's second law with regard to connected bodies. In the situation here, we have a trolley. The trolley weighs 1.5 kilograms. The trolley is connected to a weight that's going over a pulley, and the weight is 2.5 kilograms. And what we want to know is if we take out friction, so imagine that this trolley is sitting on a table and the weight is hanging off the edge of the table. If we take out friction for now, we're not going to consider friction just yet. What is the acceleration of the trolley if the weight is allowed to free fall? Okay. So step one, we need to work out what it is we actually know. What information have we got? We know the mass of the cart is 1.5 kilograms. We know the mass of the weight is 2.5 kilograms. We've got the gravity force. So that's shown as F with a small g. So we're talking about the force of gravity, and that's 9.8 meters per second. And gravity, of course, is pulling in the downward. But the motion, the cart is going to move that way. So the motion we're going to talk about as being positive because we're heading in that direction. Okay? So we're going to leave gravity for the moment because the motion is going positive. We're going to leave gravity as positive. Alright, so what we need to know is what part of the system is gravity actually working on. So the trolley is sitting on a table, so gravity is actually just pulling on this weight part. Okay, so that's the part that the force is actually working on. It's only working here on this weight. So we want to work out, well, what is the force, the net force? So we have our mass. Now, we don't add the masses together at the moment because the force is only working on this weight. It's pulling the weight down. That is ultimately having an impact on the cart, but the force is only acting here. So the mass that we use to work out the force will be 2.5. So 2.5 multiplied by acceleration, so acceleration will be gravity, 9.8. And that's going to give us an overall force of 24.5 newtons. Now, because motion is positive, that force is going to be positive as well. Okay? Now, that's the difficult part that a lot of students have trouble with. They think the mass is the combined mass, but gravity is only having an impact at this point in time on that weight. So when we calculate the net force, we only want to use that mass there. Alright, now we need to think about the acceleration of the whole, so the acceleration of the cart. And we know that our formula, we're going to need acceleration is equal to the force by the mass. So because we're bringing the cart into it, we need the mass of the two objects. So we've got the mass of the cart plus the mass of the weight, and that will give us a total mass of 4 kilograms. Okay, so now that we have the force worked out and we have the total mass worked out, now we can actually determine the acceleration. Alright, so acceleration will be our force. Now we said before the force was 24.5 newtons. And we're going to divide that by the 4 kilograms of the cart and the weight. and that's going to give us an acceleration of 6.1 meters per second to the -2, to the right or to the positive, whichever way you want to describe it. Alright, but the reality is we know that a trolley moving across the table isn't going to be really without friction. There is going to be friction there. So let's look at this calculation of acceleration when we bring friction into the equation. Okay, so now we're going to say that there's a frictional force opposing the motion at 8.5 newtons. Okay, so we know that if it's opposing, that force is acting in the reverse direction. So that 8.5 is going to be a negative value when we're doing our calculations. Alright, so again, let's stop and think about what we actually know. We know the maths, it's 2.5 and 1.5. We know we've got the force of gravity at 9.8, and we also have the frictional force at 8.5. Gravity is to the right, the frictional force is to the left. So step 1 is we have to work out the overall net force. So we're plus and minusing our vectors here, remember back from earlier on. So we're going to have 9.8 for gravity, which is in the positive, and we're going to plus the -8.5, which will give us an overall net force of 16 newtons into the positive direction. So the frictional force isn't completely overcoming the gravitational force. The trolley is still going to move in the forward direction. Okay, now that we have our total force, we can work out the acceleration. So again, acceleration is equal to the net force that's acting on the system divided by the mass. So again, this is the acceleration of the cart, so it's the mass of the whole system. So it'll be 16 divided by 4. So the acceleration of the cart this time, now that we've taken into the fact that we've got friction involved, will be 4.0 meters per second to the -2 to the right. So the calculations involving connected bodies are a little bit more complicated than the ones that we looked at before. But if you stop and think about it and just take it step by step, you'll be able to work through those types of problems. Okay, in the notes that I've put up on Compass for you, you will find a do now question. Please work through each step. It's similar to the one that I've demonstrated here. After that, I've got a couple of formative assessments that I want you to do as well. They're also on Compass, so you can have a go at those and submit your answers to me. Take a photo of your work and submit those answers. I'll explain that more to you in class. And you can now do question 11, 12 and 13 in 10.2, the review questions. Have a good day, and I'll see you on WebEx.